Have you ever thought about numbers as being part of a secret club? Not just random values, but part of a structured, harmonious family. Well, today, we're going to dive into a fascinating concept called munasaba theory, which says there are hidden connections that link numbers in ways you'd never expect. Okay, let's kick things off with a little puzzle. Take a look at these two numbers, 1729 and 7777777. I mean, they look completely unrelated, right? One is this sort of famous, quirky number, and the other is just a whole lot of sevens. So what on earth could be the secret link between them?
Well, the answer isn't some simple math trick you learned in school. It's actually way deeper than that. It turns out they're both part of a hidden network, a secret numerical code that connects them in a really elegant way.
And here it is. This is the chain. At first glance, it just looks like a random string of numbers, doesn't it? But it's actually a completely self-contained system built on very specific rules. And both 1729 and 777,777 are crucial links in this chain. So how does it all work? To figure that out, we've got to unlock the theory behind it. And that brings us to something called munasaba theory. Now, the word munasaba hints at something called relational coherence, and that's exactly what this is all about. Finding the beautiful logic that holds these secret families of numbers together.
So what is it exactly? Well, think of munasaba theory as a special field of number theory that looks for how numbers connect through specific patterns, things like repetition or their prime factors, to form these incredible closed systems. It's not about looking at numbers as lonely individual things, but as members of a big interconnected family. And this really gets to the heart of it. The whole goal is to pull back the curtain and see the hidden structures. It's kind of like searching for the music in the math, finding that harmony that's always been there, just waiting to be heard. So, how do these connections actually work? What are the rules of the club? Well, the theory gives us 5 keys, 5 secret rules, really, that unlock how all these numbers are related to each other. The very first key is repetition. This idea gives special importance to numbers made up of the same digit over and over again. We call them rep digits, and you can think of them as the big, flashy landmarks in this numerical system. They're easy to spot and often act as major anchors. And you guessed it, our mystery number, 777,777, is a perfect example. It's a classic rep digit, and the fact that it's made of all those sevens makes it a huge player here, connecting it directly to the prime number 7. Okay, key number 2. This one's all about prime relationships. We all know primes are the basic building blocks of numbers, and this theory gets really interested in how they combine. One of the stars of the show here are sphenic numbers. And ta-da! Here's where our other mystery number fits in. 1729 is a classic sphenic number because it's built from the product of 3 different primes, 7, 13, and 19. You could say this unique prime DNA is its ticket into the system. All right, key number 3, connectors. Just like the name says, these are the numbers that build bridges, linking different parts of the network together. And a really cool example of a connector property is being a Harshad number. That's any number that you can divide evenly by the sum of its own digits. Let's look at this. You've got 91 and 1729. They're both Harshad numbers, which is pretty neat, right? That's their link. If you add up the digits of 1729, you get 19, and 1729 divided by 19 is 91. See? Connected. But they're also different. One's a sphenic number and the other isn't. Okay, so key number 4 is progression. And this is all about how the system kind of levels up, you know? It doesn't stay static. It evolves, starting with simple numbers and building up to more and more complex ones, usually by adding more prime factors. Just look at this table. You can literally see the journey. It kicks off with a simple prime, 7. Then it progresses to a number with 2 prime factors, like 91. And then it hits a climax with our big sphenic number, 1729, which has 3. You can see the complexity just growing with each step. And finally, the 5th key, the one that makes it all a beautiful, complete circle, cyclicity. This is the idea that the whole system loops back on itself. A cool little trick to see this is finding the digital root, where you just keep adding up a number's digits until you get a single one. It often reveals these hidden, repeating patterns.
Okay, so we have our 5 keys. Let's put them all together now. Let's trace the entire path of our system from start to finish and really see how repetition, primes, connectors, progression, and cyclicity all work together to build this thing.
So check this out. It's not a random path at all. It's a story. It starts with a prime, 7. Then it uses shared factors to bring in connectors, like 91. The system builds in complexity, that's progression, all the way up to our sphenic number, 1729. And here's the magic link. The rule of repetition kicks in, connecting 1729 to the rep digit 777777 because of that shared prime number, 7. And to top it all off, cyclicity makes sure the whole thing is a perfect closed loop that returns right back to 1. Every single step has a purpose.
Okay, this is all pretty fascinating, right? But you might be wondering, so what? Why does this matter? Is it just a cool math puzzle, or is there something more to it? Well, it turns out these ideas have some really interesting applications.
You see, this way of thinking isn't just a one-off trick. You can take these same principles and use them to find hidden patterns in other famous sequences, like the Fibonacci numbers. Or, in the world of computing, you can use these ideas to scan huge sets of data for internal logic. It's like having a new lens to find structure where you didn't see it before.
So I think the big takeaway here is that Muna-Sabat theory really encourages us to see numbers differently. They're not just isolated points on a number line. They can form these incredibly elegant, interconnected systems, all governed by a deep, internal logic and a harmony you might never have noticed.
And that really leaves us with this one big final thought. If numbers, which are the language of the universe, right, if they have these beautiful hidden structures, what other incredible patterns and elegant systems are out there, not just in math, but in everything, just waiting for us to find the key?